Hey everybody, today we'll do another video. And today we will do a digital logic problem that is going to be part of the digital logic. I hope I put it in the playlist, but it's going to be part of the digital logic. Um, digital logic, and and we will continue with expressions, simplifying expression using boolean, using bool boolean algebra using Boolean algebra, and with the end, the oh, De Morgan, De Morgan theorem. So basically, that's what we're doing. We actually use them both because they can actually use interchangeably to simplify problems. Um, so with that being said, let's get it started, right? So that's what we're doing, right? What we actually doing is simplifying problems using these tools. Using this these tools, right? So basically Boolean algebra and the Morgan's theorem, right? That's basically they call it the Morgan's law, the Morgan rule, whatever. It's the same thing. It's basically the same thing. Okay, so basically, in order to do that, we need to understand some rules from this Boolean algebra and 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 these rules are are the following. So number one says that a plus zero equal a, right? And then we have number two, a plus one, right? Because we do it. Let's understand that over here we doing Boolean. Basically, we doing Boolean. We doing computer mathematics. In computer mathematics, that do not add one plus one. One plus one in computer mathematics is one because we're dealing with the binary numbers, either zeros and ones, right? So, so right here in this case, if we want to say that this is going to be, let's say that a was one, right? If a was one, this was one, right? Because one plus one is equal one. Now the next rule is a. The next rule is a multiplied with zero is equal to zero, right? And then the next one is or is a that one is equal to one, right? A multiplied by one is equal to one, right? If a was one, this is equal to one. In five is going to be equal to a plus a is equal to a, right? Why? Because the same thing, right? Assuming that a is one, this is one, and assuming that this in algebra, if I have in normal algebra, if I have a times 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 a, right? Times a plus x plus y plus a plus y. I can factor out, I can factor out a, and then I multiply my a times this, which is basically, a squared. But in this case, we're not doing that, right? Because we're just dealing with digital, right? Now, right here, pulling an a out, I get a x plus y, right? I factored out a. So, so basically, so it's saying that rule 5 is saying that a plus a is equal to 1, and 7 is 6. I'm sorry, 6 is a dot a, which is multiplying a. And I will explain that this basically in Boolean algebra, we're dealing with two major gates over here with using n, and we use o, right? Those two main ones are involved here. And I think if you watch my video when I did a C++ male and female, God created them, right? I used this rule to prove that male and female, and God created them. That this the one that makes sense, right? In order to multiply things around. We can see right here that a plus 0, a times 0 is equal to 0. That's why God chose this word, not that one, because this can be interchangeable, right? This can be one. This is 0.1. And also this is 0. It does say, for example, 1 plus a. If a was 0, that's also equal to 1, right? But 1, so can be interchangeable. This one cannot be interchangeable. This one is either, if one of that is 0, then it's equal to 1, a 0, right? So in other words, in order to make this sense, it's going to be a dot b is that b is equal to a b, which is a combination. But if I have a, which I am going to get explain in a minute, a not b, which is equal to a not b, to a dot with 0 is going to be 0. That that's why male and female is the one that makes sense, right? That's why I created a computer program that, yeah. And you can say, well, I can get 0 out of the, I can get 1 out of 0 using the 0 factorial, but that was man-made. That's not pure mathematics. That was that definition of mathematician, that 0 factorial is equal to 1, but 0 factorial is just an assumption that the mathematician created. But 0 will not, in real life, will not ever equal 1. So yeah. But anyway, I'm not gonna go through that because, again, I am not here to. So also put on my disclaimer over there that I did not do it at the beginning of the video. This is a Christian channel. If you don't like anything that was what I said over here about Jesus or about God related, then, but do me a favor, if you don't like the video because the content, just let me know that it's about the content. But if you don't like the video because I mentioned Jesus, also mention that you don't like the video. If you give me a thumb down, just do me a favor, state in the comment and say, I don't like your videos because you are a Christian, and I have no problem with that. But if you want to, give me a dislike because you don't like the content, also let me know so I can improve it, right? But again, if you say that you don't like my videos because I am mentioned Jesus in this channel, then if you dislike my videos for that, then I will not retract myself for mentioning Jesus. Don't matter how many dislikes you give me. If you want me a trillion of dislike, it's fine. I don't like. I don't care. I take anything. I take whatever I get for Jesus Christ because He died on the cross for me. You did not. So nobody of the viewers of this channel, if he died for me in the cross, what Jesus did. So that's why I will not retract about that. I will always maintain that my position as a Christian, and I will never retract. This is a Christian channel. This is a Christian engineering channel. So therefore, if every once in a while I have to talk about Jesus, about the Bible, about how good God is, right? Okay, so this is equal to, okay, so this is equal to A, right? So that is equal to A, according to the rule. That is equal to, that's equal to A, okay? So, and then number 7 said that A and 0 is equal to 0, right? Is that what I said, right? If this was B, right, male and female, and if one of them, and then if you have a male, male and male, right? Male and male, for example, you want to do the A's and A's are equal, and then but you want to say, oh, one is a female and one is a male, then that's going to be equal to, okay, so you say A, I compare A and B, right? But you say A is a female and B is a female, then it's going to be equal to 0. That's what it is. Okay. But anyway, so so this is how computer numbers work. Okay, so in number 9, actually, matter of fact, that was number, this was number, okay, so number 6, let me just rectify this. Number 6, according to this, which doesn't matter the order, but it's good. You understand? Number 6 is technically, let's see, which one did I, okay, A dot A is equal to 0, A dot 1, 4, right? And number 5 is A plus A is equal to that. And number 6. So, oh, okay, so they have a number 6, right? So number 6 is also, they have a number 6 like this, right? So they have A dot A, or with A is also equal to 1, right? That's another rule. Because you can say also, you can say that A is 1 and A is 1 is equal to 1, right? Now, number 7 is A dot A is equal to A. And then number 8, number 8 is number 8, right? So number 8 is 8 not with A, 8 and not A is equal to, in this case, it's equal to 0. And that's why I tried to mention it before, that is how, things are, logical things. And that's why it's one of my favorite, subjects, because that's what makes sense in human reality. A lot of people don't understand that God created things the way that they create because it makes sense, right? You have a light and you have a darkness. You have a day and you have a night. You have evil and you have it good, right? So what part of that we don't understand? I don't understand the logic behind the geniuses of the scientists that don't believe in God, and God created this stuff. God did not create a boolean algebra, but we can actually apply boolean algebra in the real life to understand logics, right? Of reality of yeah, reality of human beings, I will say. So number 9. So number 9 is what? Number 9 is, it's not A. So not A. Number 9 is not A. Not A double bar like this, right? Not A double bar is equal to A, right? Why? Because if I am negating A, right? If I do, if I do, if I do something like this, A, right? Minus A, right? Multiply my minus B. Okay, so what is going to be the product, right? Well, this number is going to be, if I multiply that inside using real algebra, normal algebra is going to be A, B. Okay? So right here I'm negating A double. if I have a not A, okay, not A, this are the two negative. Think about this two negative is equal positive, right? And then that is equal to simply A, right? So so um that's how this is stated, right? Now number 10 is it says that number 10 is equal to A plus AB, A plus AB, right? A plus AB is equal equal to A plus B or A or B, right? So now how do I get that? Well, I get that because if I do this, if I factor out A, right? Okay, if I factor out A right here, I get that. What do I get? I get A, I get A plus 1 plus B, right? Now, what is going on here, right? If I factor out A, I pull out A, right? This is equal to 1. Now, look at this. If A is 0, if A is 1, okay? If B is 1, then A plus okay, so if A is 1, let's say for example, A is 1, this whole thing is equal to 1. But if A is, I'm sorry, if B is 1, that whole thing is equal to 1. Multiplied by A is equal to 1, right? It's equal to 1. Now, think about this. If B is 0, and then I just get, again, the same thing, right? A, whatever, all equal to 1. Whatever, it's going to be one of the two, right? So um that's because I can factor out, pull out A over there, and I get 1 plus B inside. Now, now, now the next one, that's number 11, right? Number 10, I'm sorry. Actually, no, 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 no. Number 10, no, number 10, let me, okay, because this is, like I said, you can work this out different way. Number 10, on number 10, I have exactly the same thing, right? But they saying that is equal to A. I just prove it to you. How did I prove it? By pulling out A. If I pull out A again here, if I pull out A, and I get 1 plus B, if B is 0, which is equal to A, 1 plus 0, right? Multiply A across, is going to be A. Okay? Next, 11 is the same thing. 11 is the same thing. So 11, just A plus A B is equal to A plus B. Okay? Now, that's number 11. Number 12, which is the last one. Number 12. Okay, number 12, number 12 says A plus B, A plus B, and then I get A and A plus C, right? Times A plus C, right? Now okay, so right? This can be written as, using the distributive property, can be written as A plus AC. No, A plus BC, right? BC, right? So those are the rules that we actually the most common rule that we common, that we use in this topic, right? And we can actually start with a problem then, now using this little table, mm, to solve some problem, and we will do one that says, it says the following. It says that A, right? And it says, oh, another thing that I forgot to mention over here before we go through, that we're dealing with this, the most common, right? So when we have a plus like this, that becomes multi multiplication, or n, or becomes n, n, and n becomes o, right? Right? This, when we manipulate the algebra by changing the sign, we manipulate those. They change each other. That's another rule that, okay, that we need to consider. Now, Boolean algebra state that let's y equal, okay, let me just do it this way. So let's say, for example, that you have a function x is equal to x, function y, or whatever, right? Okay, so you can say it like this, right? Function s is equal to x, and then another function of, whatever. Um, Actually, let's do it this way. Let's assume that y equal a, and 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 x, right? X is equal to a, right? X is equal to a, and y is equal to b. Now you can say that x, right? X, y, double bar like this, is equal to, see, I got a multiplication sign in the middle here, right? Is equal to x bar plus y bar, right? So that's another rule. Those are considered that if a and b, if x is a function is equal to a, and b is another function is equal to b, then you can write the two functions and over the with the bar over like this, and separate them by using this rule. So I had a multiplication becomes a plus. If I had a plus in the middle over here, that will become a multiplication here. That's another rule to consider. Right. Okay, so let's do this. So A says the following, says like this. So it says A plus B, and it says plus C, and then multiplying D. Okay. A plus B plus C multiplying D, right? You will be tempted to multi-distribute that inside. It makes sense, but then it's going to be complicating more the problem what one than what it is. So what we can do is the following. So now notice that this is over that D2. Yeah, that's over D. Now, what we can do is the following. We can say the following. We can say that x is equal to A plus B plus C, and y is equal to D. Then we can separate this by using this rule right here, right? Whatever we have. What do we have? This is old. This is old, right? This is or. The whole thing is or inside this parenthesis, right? This is and with the whole or inside that parenthesis. So what I can do is basically break it into pieces, right? So I can say, okay, so A, right? And break it into pieces, assuming that this belongs to this piece, this belongs to that piece, and that belongs to that piece, right? So forth. So what I can do is break this whole bar into individual pieces, right? For the meantime, right? B, E bar plus C bar plus D. I'm sorry, multiplying with D, right? Or N with D, right? N gate. Okay, and that was the N gate is the female and male because N, male and female is the one that multiplied, right? Male and male, they don't multiply. They don't, they don't procreate kids, right? That's how God designed things. Sorry, but yeah, it is what it is, right? We have to face reality, right? So okay, so now look at this. So now, if I actually look at this, what do I have? I have a bunch of um or right or pluses, I will say, and this is a multiplication with this, right? So now what I can do is the following. So change the sign. I already changed the sign of this, but notice that I have another one that I need to account inside here. So right here, this is because it was right. I have it that, and I have it that, right. And over here, also, let me just move this away a little bit so we can understand this better. Now, right here, if you notice, I have another, right. So if it is a plus, right, also becomes a what? If I am negating this, I'm also negating this. I'm changing that to an or, right? Because I'm saying that it was it was not, but now I am doing the opposite. I'm saying that it's plus, right? So so this is another thing to consider that if you have if you have a plus, that becomes if you have a minus becomes a plus. If you have a plus, it becomes a minus. Right? So now what I will do is change this. If I see a plus in the middle over here, if I see a plus, I need to change that to what? To A, right? A, A bar, right? Plus, the plus becomes what? Becomes what? Multiplication, right? Yes. And so, so basically becomes a multiplication. Yep. Becomes multiplication, right? Becomes a plus, right? Becomes, sorry, the plus and this guy becomes a multiplication because I have a that at top, right? So I am basically canceling cancel those two out. You can think about that too, right? And replacing with a multiplication sign like this, right? B, right? And the same thing with this, right? The same thing with this plus B, and then A and B, right? Okay, so notice that I'm keeping the bars, right? But over here, I'm changing in the middle. So I'm changing A plus B to A and B, or A or B to A and B, and C, and C, right? So that is equal to this, and that is equal to that. See, becomes, right? Because why? Because from the beginning I started with that, right? So I broke it into pieces and put that the little piece belong from this belong to in every single term, right? This got it one bar, they got another piece of bar, that another piece of bar, and so forth and so forth, right? Now I right here also the same thing. So what is it? It has a minus, then it becomes right, becomes a plus D right there. So so now what is the final answer for this? A not B and that C plus D, right? And also everything is a bar here, right? So now the answer should be just A, B, C plus D. Now think about this. Plus not D, sorry. If I ask you what is the answer for this? Zero. Every single one is a zero here. It's not, I'm negating, right? Oh, yeah, I mean, you can think in the other way too, right? Let's say, for example, everyone in the computer program was a zero, one, two, one, two, three, four terms. You want to become that to negate the back and say if it's one, then you become a zero. Become if it's one, right? Not one is zero, right? Well, what about to say not zero? If it's not zero, then it will be one. It's going to be either one of those two, right? Depending on how you write the computer program. Okay, so okay, so that's one of the one of the problems, right? So what we did basically, we broke it into pieces. Okay, so we broke the bar into pieces like this, right? So that is belong to this, that is belong to that one, that is belong to that one, that is belong to that one, and this is belong to this one, and of course this actually actually need to break it one more piece over here because we have another one right here. So I got this, and then I got this, right? So so what's going on here? So this right here, because this is a multiplication, this is a multiplication, this becomes a this becomes a right here, right? It's a multiplication here. So therefore, that becomes a plus, and this is stay as it is. So that's so we just dropped that. That's why we got that D bar over there. Now we start breaking things apart, right? And we start combining things. So like, okay, so not combining, but we're getting rid of the signs. If we have a minus and a plus, right, that becomes a multiplication in this case. If we have if we have B bar, it becomes just a B bar, right? And so forth and so forth. So so basically that's how we actually got this problem done. And we will do another quick problem and that will be um so so now that we know have an idea applying these rules, so we will do a problem that this is the following. So this is the following. The problem is we have a bar like this, right? And then we have two expressions. We have we have a plus b inside, and then we have a bar over here, and we have a bar going above the two. We have a parenthesis. Then we have what? We have here. We have what? We have a. Then we have ab, right? A v plus plus bar again, and we have plus AB plus AB, and then we have A, not A, plus B. Okay. Now, also we have a bar above this, and then also we have a bar and across the whole thing. So we deal with few things over here, right? If you think about it. Okay, so now what I can do is the following, right? So what I can do is the following. So I can do it the following. So in this case, what we can do is the following. So what we can do is the following. So we can break it up the same way. We can break this up, right? And we said A double bar plus B triple bar, right? End with, I can go ahead and change the sign of this using the rules and put a plus, right? Because I'm on multiplication here. I gotta can put a plus over there, right? Plus. Then we can actually what is above this? Well, it's A bar, B bar, right? Now, so the only thing that I change is this one. I have not changed anything else, but just the sign between this and this, right? Because the multiplication I put a plus. Plus this. Now, this I can actually say A plus B bar times right here. I get A double bar and plus B bar. This right here becomes what? Becomes A, right? Because A, not A, or A dot A is equal to A, right? But, but if I am negating this, okay, so you can think it that way too. You can think it of two negative becomes a positive, right? So basically this becomes A right here. A plus two does become a positive, so by you still off with one, so B B plus this plus A or B bar plus right here I got what? I got A plus B bar. And this becomes nothing but A, I got a two double bars. So remember I had a negative right here, so I had a multiplication, so I cannot put another plus sign over there. And to make making some progress, right? Now what I can do here is get rid of those bars by saying that it's only A and keeping my B bar. Okay, so now what do I have? Okay, I got a few things. Okay, so I got a few things. Okay, so I got a few things to consider. I have it this, I have it this, and I have this. Consider. And I can say that that is one. Why? Because that's one of the rules says, right? I can say that that is one. A plus B or A plus A is equal to one. I can say that it's equal to one. So this is one, right? So now what do I have left? I have it this left right? So I have 1 plus, I carry my not b down, right? Then I got what? I got a, not a, plus, not a. And remember, that not a and not b was, up to this point right now, has been a positive, right? But do I want to change it? That's the question, right? Do I want to change it? I mean, I guess I can. I mean, I can. Let's see if that makes any difference. If I change this, right? Change that. So let's do it. That a plus b, right? Not b plus plus a, not a plus not b, right? Plus a plus b. Okay, so now this is another thing right here, right? Okay, so let's say that I want to change that too, right? Let's just do it right here, right? That becomes to almost to an n, right? And those are not plus. When I say those are not, which means that not A, not B, right? Negating each other. Each one is negating, right? That's what I'm trying to say. Plus A plus not B. Okay. Okay. So now, if you think about this is being okay. So that becomes an the whole thing. This cross following alone, that becomes what? Becomes plus. Becomes a multiplication. I'm sorry. Because it was plus becomes a multiplication. Now, do I have it this? Same thing. I have 1 plus b. See that? 1 plus b. So did they make a lot of change? Probably not. They didn't make a lot of change by changing those. But it's good. It's a good practice. I believe it's a good practice. So now, if you think about this, right? If you think about this, what do I have? What do I have? What do I have? I have this, right? A, B, right? That's negative, negating each other. And then plus, plus, plus A, B, negating each other, plus A, B, not B. Okay. So you can say, okay, so what we do here, right? If you think about this, whole thing, this is zero, that is zero, that is zero, which is technically just this, and this, which is equal to one. This whole thing right here, I mean, zero. You can play with factoring and combining and doing all this bunch of things, but at the end of the day, actually, I think, let's see. Okay, I think wrote this problem. Okay, so this is the only thing that is wrong. Okay, so this is just the only thing. Okay, so this was a multiplication, right? Because it was a multiplication, that becomes because it was a multiplication, that becomes a plus. That becomes a plus. Becomes a plus. Now let's see what we have. Okay, now let's see what we have, just to see whether it's equal to anything different. Let's see. So do it again, right? This plus this, we know that is equal to 1, 1, right? Those two, right? And then plus we have a b by itself, right? Then we said plus, not a, not B, right? Plus A, B. Okay. Okay, so now, if you think about it, if you think about it, I get this and I get this. Now I can say that, I can say that, I can say that 1 plus getting that by itself right here. Uh, yes, yes. So getting that by itself over here, I can actually say that this is equal to another one. So plus 1, right? Plus A by itself, plus this guy plus A bar, plus A bar plus times B bar. Okay? So no, look at this. The same thing. One, why do we have this one? Right? It's because of this. B not B is equal to 1. I got in my 8 over here, then I got in my A, A, not B, which is equal to 0. And again, this is nothing but just 1. So the whole thing, no matter, you even simplify it, it's equal to 1. So actually this was not A, sorry. A. Yep, it become not A right here because this is supposed to have triple bars. And 1 bar. Okay, so now the same thing, right? So if this becomes even like this, right? 1 plus 1 plus not A, which is 0, plus not A, the whole thing is equal to 1. Okay, so I just want to just show how you can break it down, using this. I mean, and again, you can go back to this and compare what we did and make sense out of it. Thank you for watching, and I see you in the next video.